In this video, I'll be talking about stationary points and finding the nature of stationary points. So to start off, what is a stationary point? Let me just draw a graph to explain it to you. Let's say our graph looks something like this. And the points I'm marking on the graph are the stationary points. That means it's the point on the graph where it changes direction. So when a point is a stationary point, the gradient of the point is 0. So dy dx equals to 0. And another word for stationary point is a turning point. As you can see, when you draw a tangent to these points and find the gradient of them, it would be 0. Now let's move on to solving a question regarding stationary points. So our question is, find the stationary points on the curve y equals to x cubed plus 3 squared minus 9x minus 4. Okay, so first of all, they are asking for the stationary point. So we know that the stationary point, the dy dx equals to 0. And we can use this to find the dy dx. So now let's find the dy dx of that equation. So that will be dy dx equals to 3x squared plus 6x minus 9. And since it's a stationary point, we can do 3x squared plus 6x minus 9 equals to 0. As you can see, it's a quadratic, and you can just solve this quadratic. So this would be negative 3, and this would be positive 3. Okay, so 3x minus 3 equals to 0, so x would be 1. X plus 3 equals to 0, x would be negative 3. Now that we found the x coordinates, we can find the y coordinates by substituting our x coordinates into the equation above. So y equals to 1 cubed plus 3 times 1 squared minus 9 times 1 minus 4, giving you negative 9. And when x is negative 3, substitute it in, so that would be y equals to negative 3 cubed plus with negative 3 squared times with 3 minus 9 times with negative 3 minus 4, giving you 23. So in conclusion, our stationary points are 1 and negative 9 and negative 3 and 23. Now we can talk about the nature of stationary points. So to find the nature of stationary points, you need to differentiate your differentiated equation. What that means is you need to find the second derivative. So you differentiate your differentiated equation, if that makes sense. So the nature of stationary point helps you find the maximum or the minimum point. What that means is when you have a graph, so when you have a graph and you find a stationary point, you want to know whether that stationary point is a minimum point or a maximum point. So finding the nature of stationary points helps you to find that. So here's what you need to know. When the second derivative of your equation is more than 0, you get a U-shaped graph, and that is the minimum point. On the other hand, when your second derivative is less than 0, you will get an upside down U-shaped graph, and that is your maximum point. Now we can move on to question asking about the nature of stationary points. So our question is, determine the nature of stationary point on the curve y equals to x cubed plus 3x squared minus 9x minus 4. Okay, so from the previous question, we know that the stationary points are 1 and -9, -3 and 23. So when you find the dy dx of that curve, that would give you 3x squared plus 6x minus 9. Now let's differentiate that to find the second derivative, and that would be 6x plus 6. So at the point 1 and -9, our second derivative would be 6 times with 1 plus 6, and the answer is more than 0. So the point 1 and -9 is a minimum point. So now the point -3 and 23, when you put x into the second derivative, that would be 6 times with -3 plus 6, and the answer is smaller than 0. So the point -3 and 23 is a maximum point. If you were to sketch a graph, you just plot your stationary points and then connect them, and so your graph would look something like that.